a pleasure to be with you here today. Here today to talk to you about some factory layout design, which is pretty exciting for us and something we work on a lot. But Mark, if you can go to our agenda, please. Thank you. So for our agenda today, I'll quickly give an update on RAND and IMAGINiT. I'll also give an overview of our webinar series and more specifically today's topic. Mark's going to walk you through the different methods for laying out a factory, and then Alan's going to discuss collaboration of these designs with the different disciplines. So, and then we'll wrap up by previewing. This is a series, so we'll wrap up by previewing the next session, session 3, and open it up for Q&A. So a little bit about us. RAND Worldwide, we're a family of technology companies. We acquire, we create, we resell, we implement, and we integrate technology for our customers, and we do that to try to produce better employee experiences for our customers and then better experiences for their customers. So we do that with an extensive reach. We've got over 30 offices across North America, over 400 employees, but I'm proud of our specialized teams. On the sales side, we've got over 140 specialized salespeople, and then on the engineering side, we've got over 170 subject matter experts, really with all the major engineering competencies. So just to explain the structure of the company, over to the right, the circular diagram, RAND fits in the middle. That's our parent. You'll see that in our email addresses. We're a public company. And then the 4 subsidiaries, I'll start with RANSIM. They simply solve the world's most difficult challenges digitally. So very substantial ANSYS partner, second largest in North America. So do a lot of simulation with a bunch of smart people that understand some complex ways to model problems. RAND 3D works with big aerospace, auto, and product companies to help document and adopt their design and PLM workflows. Sense, our documentation services group that really spans anything from product manuals for training, which many of you have probably used, as well as we do even product documentation for companies that don't have that capability, and kind of everything in between, but really document experts. And then finally, we're representing IMAGINiT here today, a large partner for Autodesk. I think we're the 3rd largest in the globe, but have a lot of resources, both to resell the software, but we've built, like I said, a large engineering team to help implement and integrate Autodesk technology. And then as you look around those 4 circles, you'll see our strategic partners. So we've been in business for 40 years. Along the way, we've collected acquisitions of companies, but we've also collected strategic partners. And after 40 years, that's what we've come up with. We've been really picky about who we choose as our partners, but we have some great ones up there. Next slide, please. So being big, I kind of talk about how big we are. That's great and everything, but I last time talked about Scott Wolfslager was in my spot and talked about all the industries that we serve, and I thought it would be nice to kind of help you understand our teams. And although we're large, I think what really makes us unique is that we've got industry-based cross-functional teams that all can work together that build solutions that span things like infrastructure, building, and manufacturing. And we also step into a little media and entertainment as well. So they really kind of span that design to make or construction, and we can leverage this across the board, again, in a cross-industry type of way. So if I look at this diagram, Kevin up in the upper left, he's got an infrastructure team. They do civil work and stuff with water and things like that. Joe's team is a substantial building and construction team of experts. Carl's more around manufacturing design. data management. I mean, we're really Autodesk's most trusted partner. We've done some of the biggest data management implementations on the planet, which is actually important in this whole factory design thing to manage the data around it. Tim's team, automation from a process perspective, but also desktop. So when I talk about standard equipment models today, Tim's team helps automate and standardize those models. And then Sean's team at the bottom helps us integrate all this stuff, and where there's gaps in the technology, they help build solutions around how to figure those types of problems out. So I'll step into the next slide, please. I'll step into the webinar series, and I just want to take a few minutes to overview what the series looks like, and then in particular, the webinar that we're talking about today. So, and then I'll go ahead and turn it over to Mark and Alan to talk about more of the kind of specific fun topics. So in our last call or webinar, the focus was around reality capture, both for brownfield and greenfield projects. And the team had talked about the digital twin and how scanning can accelerate the process to that journey. They also talked about ways to capture existing conditions, brownfield type conditions without a tape measure. It makes it a lot more fast and robust with scanning or reality capture, and how to turn a scan into building information model components. And then the other piece that they talked about was using scanning to maybe capture and reuse existing physical assets as digital assets, things like machines and equipment that may already be out on the shop floor. So in this webinar, we're going to talk about the methods to lay out a facility and how to leverage that design for better collaboration with teams. Next slide, please. Thank you. So just from a very high level, these are some of the use cases that we see and support. So things like design and prototyping of the factory, collaboration, both internally, but also with external partners, simulation of the factory before it's real, training and simulation for how to do something or for safety, for example, and then leveraging rich data to make better decisions, better estimates, and mitigate the risk of spending money in the wrong places. Next slide, please. Yep. Oh, Mark, I'm not advancing, hopefully. Oh, there we go. Okay, sorry, there's a little lag there. So if I dive down a little bit deeper into some of the common use cases, you'll see in the next few slides, I'll start to kind of disseminate our view of the digital factory specific use cases, workflows, and then the assets that are used. So here you can see a list of use cases that we leverage to better understand our clients' digital factory requirements, so how they do things. So we see these common across hundreds of businesses that we've worked with for things like capital projects or industrial equipment manufacturers and how they collaborate in design. I also highlighted some of those in blue that those of you on this call should consider thinking about if you're talking about enhancing or changing your factory design process. So some of the examples that I have up there that are common, the use of standard equipment models, and what that does is help speed up design, helps reduce procurement costs, makes it faster, and then reduces operating costs. So centralizing data by putting data at the center to help support better, faster decisions, and then enabling project management to deliver expensive capital projects in dramatically less time at a lower cost. And what we see with capital budgets, they can be tremendously big. A mistake can be very costly, and then time is very costly as well. So so we try to shorten the time of a project and then shorten those costs through So really good visibility and information. So these use cases get rolled up into work streams, right, actual processes. So I'll move to that next. So as I just stated, the previous use cases roll up into a workflow or work stream, or however you want to say it, that contain one or more use cases. So going back to standard equipment models, a model may have a development, a data standard, a change management use case that are all rolled up into one of these work streams. So I highlighted again some blue boxes and some of the standard ways that we see this for workflows that are impacted by digital factory design. So they allow for things like better, more efficient design, improved collaboration with partners, including supply chain, which is a big deal right now, and then engineering service providers, which has actually been kind of a tough thing for a lot of larger manufacturers for quite some time, especially in collecting data. And then they'll allow for quicker, more accurate estimates of projects due to better access to information. So instead of a serialized process, we're actually allowing collaboration of information throughout the process, which again shortens the time to a good estimate or a capital project delivery. Okay, next one. Okay, so and then finally, I have a list here of a lot of the assets that we typically see and that are utilized in a factory layout and design. So number one, I talked about estimates. So quicker estimates are created by doing things like using standard layouts, automations, standard equipment models. So we can build ROMs that are more accurate earlier on in the process. Drawings, general arrangement drawings, building drawings that are used to validate the design. So 3D designs especially will start to allow better space planning and enable things like clash detection as we get a little bit further down the process. And then communication tools, things like visualization files that can be used to communicate the design to key stakeholders, because including people like me that are visual, I need to see it. When I can see it, I can really make a decision and understand what's going on. Next slide, please. All right, and so this is a kind of this is an image of really the convergence of building design and manufacturing. So the idea behind this is that these two industries are getting closer, and that getting early cross-functional collaboration between these teams will really help kind of enhance that experience, again, reduce costs, shorten the time to market or time to production. So the Autodesk portfolio has come a heck of a long way in the last 5 years. I think they're uniquely positioned over a lot of the other software, engineering software suppliers out there, because they do hit both sides of this equation pretty hard. So you can now take things like a BIM model with a building envelope and the services that support that manufacturing facility and combine that into a single environment for really strong manufacturing design collaboration. So today we'll focus really on the design and the collaboration strategies, which are areas at the bottom that I highlighted in blue in this chart. We'll actually hit other areas as we move along through this series, but those are our areas of focus today. And I see they didn't highlight in blue, but that's it's really the bottom right two boxes, and then the lower left box, building design, infrastructure design, mechanical manufacturing engineering, and that conceptual definition. So yeah, our customers use these workflows to build designs with better confidence in their estimates, again, which really shortens that time to design accuracy of their projects. So thanks for listening, and I'm going to go ahead and turn it over to Mark Flayler.
All right, thank you, Jason. So we're going to begin today's meat of the session, looking at layout design and aggregation, with talking about all these pieces that make up things that you want to bring into a digital twin. Arguably, this is one of the more important aspects about digital twin nature, because without assets, without things that you can point to, call upon, get metadata on and track, digital twins kind of are somewhat empty without their assets. So we're going to talk a little bit about point clouds, rasters, 2D as-builts, architectural models, and equipment models. Now, these are things you typically face in capital projects or projects involving a digital twin very commonly. However, so many things exist as an asset, and there's a lot of different ways to think about them, to work with them. There's a lot of moving targets a lot of times with these things. You know, especially the word as-built, you see that used anywhere. Things can dynamically change at different times, so you might be thinking that you have to start taming the bear. And you know what? You're right. You have to tame this bear. You have to get these assets under control, and you have to manage them in a way that's collaborative and is easy to disseminate information and easy to manage that information. But in the end, these are all digital twin assets, right? So having good digital twin assets will lead us towards a federated factory model. So essentially giving us the digital twin we so desire. So you can imagine that this building here without all these assets in it wouldn't really mean much, right? So once you have an understanding of your assets, once you understand the digital twin nature of layout design and why it's so important, you really start getting the keys to unlocking a digital twin. Now, just like with buying a new car, like let's say a Tesla, right? You get your new keys for that Tesla and you're all excited, you start going and you start driving, right? But what happens when it gets cold out? You forgot to condition your car battery. Well, it's because you didn't read the manual, right? You didn't actually take time to understand why we're doing certain things about this car or all the things that go on with this car, all the factors that go on with this car. So what is our manual for a digital twin? Well, essentially, it's something that we can coin a phrase called the DTEP, or Digital Twin Execution Plan. So the intent of the Digital Twin Execution Plan is that car manual. It's something I can go to and say, well, this is how you do it. This is the instruction for it. This is how I'm supposed to do this thing. It's aimed at defining the foundational framework for a project so that you're not worried about all these different siloed interests, okay? So if I use another analogy, it's kind of like the PTO, or parent-teacher organization of your project, right? Every household has to come together for the betterment of the organization. So we want to have clearly defined roles and responsibilities for each team member and contractor. We want to have strategic planning and scope definitions and deliverables for how we do things with our assets as we receive them, as we work with them. We want to be clear about project milestones and timelines and overall goals with our digital twin at the forefront of our thought process, as well as model control and quality procedures around that. Work procedures such as what technology should be used, which software versions should be utilized, how files are named. You know, these are all things that kind of go into this owner's manual for a digital twin. Now, there's a lot of benefits for it, which are obvious, I would say, but to kind of put them out there, you get more accurate digital twins by following a DTEP. You can use more of an optimized use of your space claims because it's a more true to life, indication of what the asset is. You can have upfront metadata and specifications. You're not chasing your tail trying to figure out what the flow is from this machine to that machine, or what the electrical current might be on something, right? Or what the manufacturer or omni-class data might be. You'll see less issues with project delays and scheduling because of that. You'll have stronger communication when you're working on new projects. Maybe it involves taking something from your digital twin and retrofitting it or modifying it in some way. You have a more robust starting point to have that communication. And also the overall engagement experience, right? Because with a digital twin ends up being a humongous benefit for not the communication I alluded to, but also just having people enjoy their jobs, right? Service is your product too, to your contractors, to your own employees, making sure things are connected and serviceable and easy to negotiate manner. And it can give you a competitive advantage on new RFQs by having this sort of streamlined environment or this conglomerated environment, and help you get faster time to market if you're creating product, if you're trying to retrofit something, or if you're doing an installation. The DTEP can be hugely beneficial for all these things. Essentially your owner's manual. Now, if we start thinking about a little bit more of the layouts, like how do we start utilizing some of the things that we've acquired and conglomerated, and how we start making them intelligent, right? We're always going to refer back to our owner's manual, our DTEP for some guidance, right? But we talked in our previous session, our previous webinar series, session 1, about point clouds and scanning inward. So capturing things like transportation mechanisms, like a forklift. Maybe I don't have time to model a forklift, but I have the asset there. Maybe it's a special forklift, right? It's got flame stickers on it. I love showing that, so I need to have that in the point cloud. Robots, conveyors, work cells, things that it would be painstakingly difficult to maybe remodel, right? If I can just go out there and scan it and capture it, it makes my path to digital twin a lot faster. Okay. Now, once you do have those assets scanned, this is where we start putting the cleanliness around our asset and actually start working with it more effectively. There's a bunch of points in a point cloud. It's difficult to work with, right? So we need to streamline. We need to move it down to a level that's obtainable for the asset. So we want to remove extra points. We want to fix the XYZ alignment if it's off kilter. We want to get that orientation set. We also want to make some origin points, like removing the floor. I don't need the floor all the time, right? I just need this generator and its wheels, and maybe its foot pegs, right? So we take time when we go through and we clean up that digital twin asset so it's more easily consumed and usable. Now, to go along with that further, we would utilize information from our owner's manual to say, well, this says we need to put a sketch plane down because the software we use requires me to have something selectable in a 2D environment or maybe a 3D environment. Maybe the software you're utilizing doesn't connect to point clouds or touch point clouds very easily. So when you process these, you might have to bring them in, add some extra geometry to them so they work effectively inside of a layout, right? Typically, point clouds without some sort of native reference aren't really that selectable. So again, how do we reference this? How do we keep on track with it? That's right, the DTEP. Now, what about now that I have all these point clouds, right, for things that never existed before and I couldn't get anything? What about data that already does exist? Why do I need a point cloud if someone has a Revit building that I've contracted to work with, right? So maybe I can receive an architectural model from some software that creates an architectural model, right? So you see that there on the left. I'm working on something on the inside of this where I need to have a certain portion of it, right? So building information modeling is becoming much more prevalent in new greenfield builds where you're starting from scratch and nothing exists. There's no as-builts, there's no general arrangements in place yet. So it's becoming much more common on the front end of greenfields, but also very common on portions of a building for brownfield retrofits and reclamations. So being able to bring this data in and understanding how I can bring it in, the collaboration with the external provider for how I can receive it, are all things I would typically negotiate, again, that's right, through your DTEP. And your DTEP and your DTEP and your DTEP, right? So these are all things that I have governing rules and ways I want to do things and collaborate with to accept this information for my layout, right? Now, what about equipment models? How do you get them, right? I don't need a point cloud of the equipment model because I know it exists somewhere. Someone's fabricated this, someone's made it, right? Well, typically a couple ways you can get them is through magnanimous consent. The company is saying, you know what, we love our shrink wrapper. We would love everybody to use our shrink wrapper. Here is a space claim simplified model of our shrink wrapper that we share with the world because we're magnanimous about it, right? Other times you might just get 2D drawings or PDFs, which don't initially give you a lot of digital twin energy, right? So it does help you to build things into your contract language that will say, if we do buy things from you, we would like to have a simplified asset. If you are contracting someone to design something for you, that certainly should be in your contract language. So a lot of the times these things are missed, or a lot of these things are not thought about. Maybe there's something that, maybe this doesn't exist yet. We're still in kind of preliminary phases of thinking about what this will be. Well, you can use some generic asset libraries or some generic space claims that have a low level of development. So it's just a box or a cube of some kind that takes up that space initially while you're going through the process of design that your contract language and your providers will end up hopefully providing to you, right? Now, let's say you do get the model, right? Let's say you get a really nice model, but it's not in the software you typically use, right? So a lot of softwares can do what's called referencing rather than conversion. With conversion, you are converting something from a non-native file to a native format, right? If things never change, if you're never getting updates from that model, that's an okay thing to do. You can convert it. But if things are always updating, I'm always getting new versions of this piece of equipment throughout the project, right? Then referencing it can become a much more powerful answer to that. Because if someone changes something, it will update then automatically in your layout. You don't have to retranslate it in or reassemble it where it needs to be. It just updates, right? Now, what if through contract language or through the betterment of the project, you just are not able to get a 3D model of a digital asset? Well, maybe you need to create your own simplified version and add that to your library of assets for things you're going to use. Maybe you do have a full fabrication model, which does not work well for digital twins. Digital twins should have somewhat simplified assets. You may take the time to go through and simplify it and reduce some of the bolts and holes and things on it that don't really matter for what you're trying to do for the overall project. So thinking about the difference between a fabrication model versus simply this takes up this space, right? And when you do these things, you might also go through and say, well, this is a guard area. This is somewhere you shouldn't go. So maybe you have an electrical cabinet that has an arc flash radius. Maybe you have a space claim that has a translucent sphere around that arc flash distance so people can understand when they're walking by something that's a no-go zone where they're working on something, right? So what can help us, again, manage all the assumptions and all the things we're going to do about laying out our digital assets? Well, that's right, the DTEP, right? You refer back to the owner's manual. Now, as you go through creating all these assets, like I mentioned, right, all the things about space claim requirements, all the things about the data that goes into them, you should have a checklist of some kind. You should have something that says, if I'm going to use this for a digital twin, right, my owner's manual says to continue putting in file properties, metadata, the space claim required for certain types of assets, basically everything you know or will need to know about this in your project or for long-term utilization, right? So for instance here, a generator, I want to add in part numbers and descriptions, maybe what project it goes to, who I initially got it from, some initial cost on it, maybe a vendor. Maybe I need to have a area around it so the exhaust can freely get out and not cause problems. I might create some space claims around this point cloud as an example to that. Okay, but again, this is all going to be governed by your owner's manual. Okay. Now let's talk a little bit about the actual layout of these assets, right? So how you get the assets, we've all covered that, point clouds, working with external providers in different ways, but now it's my time to actually start laying this stuff out. Now, a lot of this will typically start with a whiteboard, right? So you're this guy up there saying, I'm going to go ahead and I'm going to lay this out here. It's kind of a spaghetti diagram, right? Nothing doesn't quite exist yet. Works great for general meetings for visual learners, right? So this is somewhat of an analog layout. The problem with this is you can't capture that unless someone takes a picture of it, right? And then what does that do for you? Well, nothing, right? So I do have some clients that still go through and lay out cardboard boxes on the floor, okay? That is not going to be great for digital twin because you can't really leverage any of that later downstream for simulation or for model aggregation. It's just conversation pieces at that point, right? Which is fine. Now, hopefully you don't go to this level, right? Hopefully you're not actually going to start taking some corrugated cardboard and start making equipment out of it, right? This is very much not necessary when you have 3D digital assets. So usually for analog layout development, this is very old hat, but it can be very preliminary and still has benefit in laying out your generalized assets and such. Okay. When we start thinking about digital, though, this is where most people have lived, right? You start thinking about 2D layouts and general arrangements. If we focus on factories as a focal point, about 95 to 98% of all factories have a 2D plant layout. It's very common. A lot of times they'll include X references linked in as rasters, right? PDFs that are brought in, TIFF images that I might consume inside of that general arrangement for things that I don't readily had drawings or as-builts for, right? A lot of times these don't get the attention they deserve to be updated accordingly. Mostly because people have to think in 3D but work in 2D. The Z factor kind of goes out the window where you start running into obstructions. I put this piece of equipment in, it looks good on 2D flats, but oops, I hit a pipe, right? Or I hit an HVAC line because I didn't think that height was going to be an issue. Or I couldn't get through the doors because I didn't take into consideration the height of the doors with the height of the equipment that I'm bringing, right? So a lot of times having layout software that's simply 2D will have some issues with it for a digital twin, right? Now, can you still assign data to blocks? Yes, or cells or whatever you want to call them to group data together. You can still assign some data to them, but it's really a lacking digital twin, okay? It's definitely a lot more difficult to express changes and issues, but I think we can all agree that 2D is a very common currency inside of engineering, right? A lot of people consume 2D data very readily because of viewers and the portability of 2D in a lot of ways. And that has been changing, right? So is there a way that we can leverage 2D with 3D? Well, absolutely, and we'll get to that, right? But this is usually a starting point for a lot of digital twins, okay? Now, if I think back to that generator, I put a little sketch on the bottom there, some 2D representation. I can use that and start bringing some of those two-dimensional blocks in and still kind of work with that a little bit too. But really, everything's been shifting towards 3D more for integrators, for layouts of factories and facilities. It's so much easier to collaborate with a 3D model, right? And here you can start consuming things like buildings from an architect, or if you create the building yourself, or assets, right? Different types of digital assets like point clouds and equipment models, things which can have more detailed information about what's really going on in areas of safety concerns or issues like that. So here you're starting to actually think and work in 3D with this full representation. In the lower right image here, we can see a robot arm that we put a sphere around to understand its total range of movement. And by having that in 3D, I can see really what's going to go on with how this thing's going to move and rotate. And if I need to tell the programmer to not go a certain height to risk hitting something, right? Or what happens if we do hit something? Maybe I should just actually move the HVAC line. So you can do a lot more with collision detection in a 3D space. The metadata is intrinsically more available with 3D assets of some kind, whether it's a point cloud or an architect model or an equipment model. So what about the best of both worlds? Is there a world where I can utilize 3D visualization and communication, but also have 2D deliverables and assets which are general arrangements and still have them linked together? Well, yes, right? And it's not what you think, right? You may be thinking if I have a 3D parametric modeler, I should be able to create a drawing for that. Well, yes you can. But some softwares, and there's not a lot of them that do this, will allow you to work in 2D, move something around, and then it affects the 3D model automatically. So if you have stakeholders which are primarily focused on the 2D layout of things and they have an easier comfort level inside of that, they can shift the safety gating a foot north, right? And in the 3D model, that will automatically update. They can be associatively linked together so that your deliverable can still be a 2D drawing, but you're getting all this power and benefit of 3D visualization, right? Of having these point cloud assets and architectural models. Okay? Again, all geared towards an integrated factory model. It's giving you the basis for a lot of things that Jason talked about, like supplier exchange and information flow, virtual commissioning and simulation that we're going to see in the next session. And lastly, aggregation, visualization, and even augmented reality, if that's one of your outcomes for a digital twin. Okay, so again, how do we keep all this on track? How do we keep everybody talking the right language and on the right sort of timeline and project schedules, and understanding who has ownership of certain things and whose responsibility is what? That's right, the owner's manual. Going back to the digital twin execution plan. Okay, so from here on, I'm going to pass this over to Alan, and he's going to talk to you about a little bit more about aggregation and why that's important, because not everything can exist in perhaps your layout software. Maybe not everything can be brought into your layout software, and maybe the collaboration of that digital twin needs to be a little bit more expanded out for collaboration. So, Alan?
Thank you, Mark. So to expand on everything that we've talked about so far, we're going to hear essentially an intermingling of terminologies. I'm going to approach this from a little bit of a different perspective, being from those architects and engineers and contractors that you're going to be collaborating with at some point or another, certainly through design and construction and into turnover back to you for operations. So what are some of the, where can we gain value from these 3D models that we're going to create? While we're never going to, not necessarily never, but the 2D process, as Mark has alluded to, there's a lot of value in the 3D because we essentially are working in a 3D environment. We can be living in 2D and move it a foot north, and it moves both in 2D and 3D, and that's the value and the benefit of some of the parametric and 3D environments. So ultimately, what is our goal? And that's the reason we're here for this entire series. It's that digital factory. Well, the point being, obviously, if we're in that brownfield situation, we're trying to catch up, and we do go capture that, do the reality capture, we get that point cloud. That gets us up to date with into that as-built status. Or if we're in greenfield, we want to start off with the begin with the end in mind context. We want to be able to, we got to get out of the gate with that model-based process so that we're not having to go and reinvent the wheel and come back and do rework. So what are our goals? What are our objectives with a model-based process for our digital factory? Well, for the phase of construction, what is ultimately a couple of the most important things, really kind of the end all and be all, is to make sure that we're on time and schedule. Well, how can we facilitate that? What is going to be a more informed process and just a cleaner handover, an entire delivery, a 2D world or a 3D world? And as Mark was alluding to, we all communicate in different forms, or in different, we all visualize in different ways. Those of us who are potentially in this stuff every day, all day long, we can work in 2D and visualize it. But those of us who are potentially those stakeholders who are not in it every day, and they're just trying to, they've got their own work and their own tasks, well, that model is always going to deliver that picture. A picture's worth 1,000 words. For operations, what's another goal? For operations, we want to make sure that we are informing our facilities teams downstream, that living and breathing environment, the digital twin environment that is reporting information of our equipment back to our interface, our digital interface. Those things are goals So a model-based environment is going to, as we were referring to, it is intrinsically, these models are intrinsically infused with more data, a more comprehensive data set. So what is some of the worst issues we deal with in design and delivery and project delivery? Communication, it's always siloed and broken. Well, with a more comprehensive model-based process, you have more information at your fingertips, and you're able to go and access that information, right there on your desktop or even on your mobile device. And as I was saying, the 3D representation is just a better communicator. If you're able to look down on plan and then you're able to actually look up and see it, as Mark alluded to, the VR and the XR environments, these virtual reality environments, they help us to be more informed and enhance our communication. Next slide. What are some of the additional benefits as we referred to spatial coordination, spatial representation? We want to make sure that as we're working, that visualization is as easy as possible. And that's what these 3D and model-based environments afford us. And in doing that, in having that environment, the spatial consumption of your equipment, your air handling equipment, your actual factory lines, etc., we can identify problems, as we saw with that with the robotic arm. Hey, we gotta move the HVAC. Well, how does that impact people downstream? Well, that contractor is going to need to know that potentially, and if they're informed through a model-based execution, they can potentially send an RFI earlier, or they can just communicate, obviously communicate the issue potentially once they come across it in the digital environment, rather than once we have the physical environment already built, and then it becomes a much more costly change. It allows us to be in a more proactive footing. The information, it's super, super important. And here's something that's always problematic about our work is we don't necessarily understand what our colleagues or the folks that are at the other building or what have you. We could be working literally one cubicle over from people that we don't even necessarily understand their engineering or design process or their discipline. Well, when you have those elements in space digitally, you can understand, as we talked about, the electrical equipment that has to have by code X amount of clearance zone. So now I understand what you're doing because I can see it in front of me, and it is communicated as easily as possible. And it removes those excuses. Hey, I didn't know it was there. So TMI, we all deal with this. There's so many formats. There's so much. We saw that earlier with the various types and formats of software and file formats. Well, we have to have the aggregated, we need an aggregator to bring all these together so that we are literally seeing everybody, and we need tools that afford us that ability to get all the people in the same room. Next slide. So design collaboration, and when we're talking about design collaboration, we've all been there, we've done it, we've been doing a process of sharing information and linking each other into our own files, and we see where the other disciplines are, and we react, and we go and develop our designs from there. These are the traditional 2D format is that conventional process. Well, what can a collaborative design process, model-based process deliver that we didn't have there? And well, collaborative design teams have, again, models that they can react to, because what's going on today with the changes that are happening, certainly in technology advancement and so on, let alone supply chain concerns, whatever the case is, we have to be as quickly, we have to turn around our changes as quickly as possible. And so we're all in a singular environment where we have a common data environment, as we'll call it, that digital twin, everybody's all in one place through the design process, let alone, that allows us to just react as quickly as possible. And again, the whole stakeholder and the visualization, the people who need to make a decision, however possible, we can give them that picture as quickly as possible. That's going to allow them to make those hard decisions. What is most critical in our everyday life, let alone our work? It's time. Every second counts. We know this, we deal with it. We don't like to be sitting and tapping our fingers, waiting for something to upload, that we have to do that 5 times a week. Well, if we're in a collaborative, potentially cloud-based atmosphere, we're able to share information. We get it up in the cloud, and now it's there, and it's living and breathing, and it's iterative, it is synchronized, it's real time. That information doesn't have to be shared time and time again. We can schedule an automated process of sharing that information. And ultimately, it reduces that downtime. We don't want to have to go get coffee again, waiting for something to process. Next slide. And ultimately, yes, the digital twin execution plan is what affords us that those changes. So why are we doing this? Why are we talking about this right now? Well, it is out there, it's in front of us. We all hear about it every day. The world, the technology that is available to us, it's changing. There's data sets are growing. Again, that whole TMI, there's just so much, there's so many ways to create things, and there's so much information in front of us. We need to be able to increase the efficiency of our currently siloed processes. Again, we have information, we're executing tasks here, and then I have to maybe download it to bring it over there. Well, that's why we have these collaborative single source of truth environments, so that we don't have to we can connect our data. It's out there, again, AI, everything is just exploding technology-wise. We really need to jump on the bandwagon now, or else we know our competition is doing it. It's just going to take us a while to catch up. So let's see. So how do we do these things? What are some steps we can take to introduce this collaborative advancement in our digital transformation towards a digital twin? What are some of the steps we can take? Well, again, introduce the model-based process. Put that into your plan. Put that into at the very beginning. Install that. It's an SOP. We stick to it, and we move forward with this plan in place. We define it, we document it, and that ultimately is what becomes this digital twin execution plan. All right, I think, yeah. So Jason, back to you.
Okay, thanks, Alan. Appreciate it, Mark, Alan. So we went a little longer than I expected, so I'll make this brief, but I did want to point out our next upcoming part of the series will be about model simulation and coordination. So once the design is done and what we talked about today, doing some visual validation of that particular design, make sure it's going to meet our needs. And we'll also start to talk about things like simulate how you might build a factory, 4D simulation. And one more, and I'll wrap it up, and we can go to Q&A, Mark. Thank you. So again, next series, we're going to talk about really the right side of this chart. So the third small box from the right, simulation and optimization. And I think this is really an overlooked opportunity for a lot of manufacturers, where they can save money, reduce risks, and produce either products or projects much more efficiently. Big return for manufacturers. I think it can be huge, but we have some, we work with companies to do this and have some great tools and experience in this area. So so we look forward. I think it'll be the same group coming to you next time. But we appreciate your time today. Hopefully this helped, and then we'll stick around a bit here for questions and answers. So.
Well, as always, thank you, Mark, and thank you, Alan, and thanks, Jason, for joining us today. We will see everybody on February the 15th. Thanks, guys.